This is for Year 12 Methods. It comes out of 2018 Exam 1, question number 5. So it's a maximum minimum problem, and it's the minimum of a straight line from O to P. So P is on this straight line. So -4 gradient of 2. So P is somewhere on that line, and we're looking for the length of O to P, the line segment from the origin. So P must be around about there. That to be a right angle, therefore the shortest distance. So we're going to call that x, and I'm going to call that y is 2x minus 4, because it's along the line of y equals 2x minus 4. And we're looking for the coordinates of point P. Okay, so if I look at the distance formula, the distance will be the square root of x2 minus x1, and since x1 is 0, it's x squared plus 2x minus 4 squared, because y0 is also 0. The square root of x squared plus 4x squared, 2 times the first times the second, minus 16x plus 16, and that's what d is. d dx is going to be, it's going to be a half, 5x squared minus 16x plus 16 to the negative a half, then times the derivative of the inside, which will be 10x minus 16. And if I set that equal to 0, I get equal to 0 of and my top is 10x minus 16. Since it's equal to 0, the 2 can't equal 0, that can't equal 0. This is the only thing that can equal 0. Therefore, 10x minus 16 equals 0. X equals 16 divided by 8 on 5. And y is going to equal 2 times 8 on 5 minus 4, 16 on 5 minus 20 on 5, minus 4 on 5. So the coordinates of point P are 8/5 and minus 4/5. And then find the distance. Well, if I'm going from 0, 0 to 8/5 minus 4/5, it's going to be the square root of 8/5 squared plus negative 4/5 squared, which is the square root of 64 on 25 plus 16 on 25, the square root of 80 on 25, which is square root of 16 times 5 on 5 squared, which is 4 root 5 on 5. Therefore, A is going to be 4, B is going to be 5, and B is 5. There's my answer.